Fume hoods are one of the most important safety features in a research laboratory. The hood is used to protect researchers from breathing hazardous airborne chemicals, and the sash can be used for protective shielding. This presentation demonstrates how to use your fume hood properly to better protect yourself and our environment from exposure to hazardous materials. When you use the hood, you should turn on the hood light so you can see clearly. Check the hood certification sticker. It will list the date facilities management last checked the hood, the average inflow, and whether the airflow was satisfactory. One should always check the quantitative airflow monitor or alarm to verify that airflow for the fume hood is proper. There are several types of airflow monitors used on campus fume hoods. For this video, we will show you a few of those common types. Digital monitors display air velocity into the hood and should read more than 100 feet per minute. Some monitors will only display red, yellow, and green indicator lights. All monitors have an audible low flow alarm. Some fume hoods have differential pressure monitors that look like this. Since these monitors may be different from building to building, check with your supervisor for the correct meter reading. It should always be greater than 0. If the hood airflow monitor indicates low airflow, first try lowering your sash. If this does not resolve the alarm, contact your department safety coordinator, EH&S, or facilities management for maintenance. Adjust the sash to the proper height. In this case, the glass sash was raised to the maximum working height as indicated by the joint arrow and then slightly lowered. The tissue on the sash is drawn in, indicating that there is airflow into the hood. Most fume hoods now have this label on the sash frame. Be sure to use the sash in the green zone as much as possible. A sash should only be in the red zone for equipment setup. When you are finished with your work, be sure to lower the sash and save energy and protect lab occupants. Airflow turbulence at the front edge of the hood can draw airborne contaminants out of the hood. In this case, the sash is too high, and when someone walks by, the low inflow velocity allows the smoke to come out of the fume hood. Sashes properly adjusted and working further into the hood are the best way to protect yourself from inhaling hazardous chemicals used in the hood. Move extra equipment out of your way and always work at least 6 inches from the front of the hood. Some hoods have a combination sash that can be opened horizontally or vertically. In this case, the sash is lowered, then the horizontal sash is adjusted to provide protection from explosive reactions or chemical splashes. In older buildings, fume hoods may have horizontal sliding sashes and a velocity screen to meet the 100 feet per minute inward face velocity. Horizontal sashes need to be placed in front of the work and the velocity screen lowered to maintain a safe working environment. Typically, there are no pollution control devices on fume hoods. The airborne contaminants made in a laboratory hood are exhausted from the roof stack into the environment. Never evaporate chemical waste through a hood, and when working with a hood, minimize the volatiles released to protect our air quality. When you are done using volatile chemicals, close and seal the container. When finished using the hood, close the sash and turn off the light for added safety and to save energy. In review, before using the hood, check the airflow monitor. Properly adjust the sash height for your work. Always work at least 6 inches from the front of the hood. Fume hoods exhaust into the environment. Minimize your fume hood emissions. Close the sash when you are done working in the hood. In closing, if you have questions about your fume hood, ask your lab manager, department safety coordinator, or contact the Office of Environmental Health and Safety. Also, read the fume hood safety net and other laboratory safety information available at the EH&S website.